Hello, welcome. Today we're going to be looking at representing the average monthly temperatures for Washington, D.C. with a sinusoid using our calculator. Okay, so here we're asked to determine the amplitude, period, and vertical shift for a sinusoid that could model our data, and our data is listed here. Right? Well, our period we know is going to be the time to repeat. And that time to repeat, in this case, average monthly temperature, right? If we're not sure kind of what our period is, we could graph and look at our scatter plot. So let's do that. So, good practice, go second plus 7, 1, 2, right, to clear out our calculator, and we're going to come over here and come to the stat button. We're going to edit, and we're going to put in our values in our L1, which says 1, 2 through 12, and we can get that information in for our X values. We can do the same thing for our Y values, the average monthly temperature. And so once we have all of that information into L1 and L2, what we can do is hit second stat plot, right? That was, once again, second stat plot. So if you're on the regular screen, right, where it's second edit, we have that, right? This button right here, second, and then the Y equals button, that's going to take a stat plot. We can go to this first one. We want to make sure that we've highlighted our scatter plot. Our X's are in L1, our Y's are in L2, and we're going to come over and turn our plot on. And the next thing we can do is hit zoom, and if you look at the bottom, number 9 says zoom stat, so then hit number 9, and we have, right, our graph. And it seems to be that this data looks to have about a period for our function. Okay, well, if that's the case, then we now have our period. And that is that the time to repeat is the 12 months, so about 12. Okay, our amplitude is going to be our max minus our min all over 2, which in this case the maximum, if we look at our values, is 80. Our minimum, if we look at our values, 39, 37, 34, so it looks like 34.6 divided by 2. And that amplitude is 22.7. Okay, and then our vertical shift is 57.3. How did we get that? Max plus min all over 2, maximum plus the minimum over 2. That's our vertical shift. So what does that tell us? We have a center line at about 57.3, and we're going to go 22.7 degrees above that and 22.7 degrees below that, and it's going to take about 12 months for us to repeat that pattern. Okay. Now we're going to say, hey, use a calculator to find a sinusoid function of this form that models the data. Well, if I have a nice table of values, here's what I can do to get that equation. I'm going to come over here to stat, make sure all my values are in L1 and L2, right? Then go stat calculate and arrow down or arrow up until you get to sine regression, right? Select that using enter. Leave the iterations alone for now. List 1, yes. List 2, yes. Okay. The period, if you're not sure about the period, you can leave the period blank. And then for storing your regression equation, I always recommend that you store your regression equation. And what you can do is hit alpha, calculate, go down and select a value where you know you don't have another equation. If you are not sure where you don't have another equation, you can just double check. No equations. So stat, calculate, sine regression, select iterations. Don't worry. Make sure the X list and the Y list match. If you're not sure about the period, don't worry. store the equation, alpha, calculate, and I'm just going to store that equation in y1. And we're going to press enter. Okay, so it's given me this equation, right? And notice that A is very close to 22.61. It's very close to what my equation was, right? B, 0.50, right? Well, how do we get that number? We're going to check that out in a bit. C, right? That represents a phase shift. And then D, 57, right? That's very close to our number here. Okay? But what's important, if we go to y equals, guess what? Those numbers are in there already. Okay? So once again, what was the process that we did? Step, calculate, sine regression, leave everything, right? We stored our regression equation, alpha y equals into y1. We calculated it, and our equation is y equals 22.61 sine of 0.503x minus 2.04 plus 57.2. Okay, that seems to be our equation. And then we're going to ask to draw a model for that data. And so we can hit graph, and we can look to see how good is our model, right? And it seems to fit that data pretty well. So now we're just going to need to graph that. What's going to be the process? Well, that process is the same as always. We set up our piece, right? Our center line is at 57.2, right? 22.61, right? Plus 22.61 minus. Okay, and we look and we see and we check, right? And so we come over here and we're looking at our graph, right? And we see what we have, and we say, okay, well, that's about what I look like. All right, so if I check that out, it seems as though I have particular areas where I have maximums and minimums. And if you're not sure, guess what you can do? Second, calculate my minimum, right? Arrow towards where that minimum occurs. So I'm going to come all the way over here, right? So left, right, guess, and that minimum occurs at about 1. Okay, now what's my period? Oh, well, I know that my period is 12, right? Now I can double check my period by doing this, right? Second quit, 2 pi divided by 0.503, and we see that it seems that the period for this data is a little bit more, and we'll say 12.5. That means 2 periods would be then 25, right? That's based on this data and a little approximation. You use 12, you use 12.5, we're going to be okay, right? But once again, if we came over here to our graph, we said that that minimum was at about 1, okay? We said that minimum was at about 1. And our maximum, second, calculate, maximum, right, we can go over towards where the maximum is, right, be to the left of the maximum, press enter, go to the right of the maximum, press enter a third time, and our maximum is at about 7. Okay, so our minimum should be at about 1, our maximum should be at about 7, right? If this is about 12, then this is about 6. So what does that tell us? That our maximum is going to occur a little bit after that. Our minimum is going to occur somewhere over here, okay? And I can check other values, right, to where this process is going to repeat. And I can come over and draw 2 periods of my graph, right? Doesn't have to be perfect, right? But generally speaking, the better you can make it look, the better it's going to be for you, okay? So that's an example from a table getting this information, right? I do want to add to this, what if I wanted to do this sort of work without a table? What if I wanted to do this sort of work without a table? Okay, so additional information. If I did not have a table, right, what I could do is use this idea from knowing where my max occurs. My max occurs when? At 7. Right? So a rough idea for this is I could say that my equation could be given by y equals my amplitude, 22.7. If I'm going to say starting at a maximum, that's a cosine, right? My period is 2 pi over 12. A phase shift would be 7 units to the right to be at that maximum. So x minus 7, close parentheses, and then say plus, right, that vertical shift, 57.3. So this is how I could get that information without a calculator, right, and have a similar piece. Amplitude, 2 pi over my period, my estimate for my period. My phase shift to my maximum, the maximum occurs at x equals 7, so I'm just going to say x minus 7, assuming that I start at 0, right? And then plus that vertical shift. And then I'm going to be able to graph this and double check how close it is to what the calculator modeled. So I come to my calculator and I go ahead and enter in the information, 22.7, cosine, right? 2 pi divided by 12, okay, and whoops, pressed enter a little bit too soon, parentheses, x minus 7, close parentheses, close it again, and then plus 57.3. Right, be careful with all those parentheses. And now I'm going to graph, and I'm going to see, right, that estimate is really close to what the calculator gave me as well, right? That the calculator gave me this first graph, but I could have, right, not even using the graph, gotten my own sinusoid based on this situation, based on a cosine, because a cosine is easy to determine from a maximum, right? Once again, what did I do there? Amplitude, start at a max, 2 pi over the period, phase shift to the max, vertical shift. Okay, that is what you need to know for these types of problems. If you have questions, please make sure that you ask.